Okay, so we're still doing lesson 2 of our first unit, graphs and functions, but this is part 2 to it. So I decided to break it up so the videos wouldn't be so long. So on this part, we're going to start out, we're talking about increasing, decreasing, and constant. So just think about it as you know it. What does increasing mean? Something increases means it goes up. Same thing. If my graph is increasing, as we read our graph from left to right, it means it's going to go up. What does decreasing mean? It goes down. So as we read our graph from left to right, it means that our graph is going to go down. And what is constant? Something that's constant doesn't change. So when we read our graph from left to right, it's going to be a horizontal line. Now, one thing I do want to point out before we move on here is if you read the definition through here, it says on the open interval. And an open interval means we're always going to use parentheses. Because you're telling me on here, when you give me the intervals, where it's increasing or decreasing. At those endpoints, it's not increasing or decreasing. So let's say we've got this graph here. I'm just looking at my solid part there, okay? So I can tell that my graph from here to down here is decreasing. All right? At this point at the top, I'm going to call that A, it's not really increasing or decreasing. That's where the change is occurring because to the left of A, we can see it's going up, so it would have been increasing. Same thing down here, I'm going to call this point B. At point B, it's not increasing nor decreasing. It's where it's changing from that decreasing to what I attempted to draw would be a constant. So we would write our interval here for decreasing as from A to B, always using parentheses. All right, and so you can read here the more technical definition if you would like. Just don't forget to read your graph from left to right the same way you would read a book. Okay, example 3 says consider the function y equals f of x shown at the right. Trace each interval where the function behavior is increasing. It wants us to use green. If you got green, great. If you don't, that's okay. You don't have to. So I'm going to take my green marker and I'm going to identify, or I'm going to show where it is increasing. So as I read it from left to right, I can see that it's increasing right here. Well, where did it start increasing? It started increasing down here at this point, which the x value there is -8. And it stopped increasing right here where that change is going to happen at, and that's at -4. Remember, at -8 and -4, it's not increasing nor decreasing. It's where the change is occurring, so use parentheses. Is it increasing anywhere else? It is. It's increasing over here on this portion. So we can see it starts increasing here at 3, and it stops increasing over here at the 6. Might be able to do the back button and get rid of those. Nope. Oh, just kidding. All right. Then it wants us to talk about, it says, decreasing using a red pencil, identify the intervals. All right, so let's turn to red here, and we're looking for decreasing. Decreasing, remember, is where we go down. And so I notice that right here we're going down. Where did it start going down? It started going down where it stopped increasing. So therefore, that would be the -4. And it kept going down to this change, which is at the -2. And again, we always use parentheses. Nowhere else is it decreasing, so let's move on to constant. So constant, it wants us to use yellow. And so I hope y'all can see this. Well, I'm trying to change my pen. There it goes. So it wasn't letting me. All right, and so we can look and we can see that it is constant in between that change at -2 all the way up to that change at 3. So between the -2 to the change at 3. So we're going to say from -2 to 3. And again, those points are where the change is happening, so they're not included. Now it wants the domain and range. So I'm going to go through, I'm going to erase this, all the colors I have on here, so we can actually see the points again. All right, so for domain and range, remember domain is your x's. So we're going to look at our x values. Remember, x's go left to right. So I look on the far left, and I see this point right here, which is at -8. And then I can see this point right here, which is over here at the, I'm pointing to the x value there, which is 6. Now, you've got to ask yourself, are all the x values between -8 and 6 being used? Otherwise, this won't be an interval and I'll have to create different ones. Well, look at your graph. It's solid. There's no holes. It all connects, so there's no jumps. So yes, every point in between -8 and 6 is included. Then ask yourself, is the -8 included? Well, look at its circle there. Is it open or closed? It's closed, which means it's equal to, which means it's included. Same thing with x is 6. Look at that circle. It's also closed, which means x is included. So those endpoints were included, so we used a bracket. Now for the range. The range, remember, is your y values. So we'll always start with the smallest, so your smallest y values are at the bottom. So look at the bottom of your graph, right here where y is -4. Go to the top of your graph. It's up here where y is 8. So I'm thinking it's going to be -4 and then 8, but I got to make sure there's no holes and no jumps in my graph. Well, we'd already said earlier we'd trace the graph, and we said it's solid, right? It continues, so from one piece of it to another. So therefore, it is an interval from -4 to 8. And then check to see if it's equal. At the -4, it's a closed circle. And when y is 8, it's also a closed circle. So we're going to use brackets because those endpoints are included. Now F says, what thoughts do you have about the interval stated above? Did you use brackets or parentheses? Why or why not? All right, so I'm not going to scroll. Let me change color. I just use that one. I'm not going to scroll down here, so I'm just going to kind of do that, and I'm going to answer this up here, okay? So when did we use the brackets? We use the brackets for domain and range. And why did we use the brackets? Well, remember, it was because the endpoints were included. And when did we use parentheses? We use parentheses for increasing, decreasing, and constant. And why? Well, because the endpoints were where the change was occurring. And not included. All right, so hopefully that makes sense. So let's keep going here. So let's look at example 4. So example 4 says using a graphing utility to determine the open intervals on which the function is increasing, decreasing, or constant. So we're going to put that into our y equals. And when we do that, we're going to get a graph that looks something like this. Okay? And so looking at this graph, we can tell as we read it from left to right that this first part here, now we may be coming from the bottom and maybe going down to the left, but remember, we read it from left to right. So what is actually happening to this graph? It's increasing, and it's increasing from that far left x value, which is -infinity, and it's going to keep increasing until we get to this point right here where x is equal to 0. Parenthesis. Then what happens? Then we start going down, so we're decreasing. And we're decreasing from where it stopped increasing, so the 0, down to this point right here that has x is equal to -2 at that point. And then what happens? Well, then my graph starts increasing again, okay? So I'm going to come up to increasing, put my little union. It starts increasing at that -2, and it keeps going up to the right, so it's going to stop at infinity. Now, on this one, we didn't use constant, but guys, don't leave it blank, okay? Put a dash, write the word none, put NA for not available or not applicable. Do something. Don't leave it blank. A blank answer is a wrong answer. All right, let's keep going. Let's look at B. Now, some of y'all might not remember how to find absolute value in your calculator. So to get absolute value, you're going to go to second, 0, and the first thing you're going to see is abs, okay? If you have a newer calculator and you're in y equals when you do this, or your home screen, but you need to be in y equals, it'll put the 2 bars there, okay? So you'll have like this, and there's a little box in here I want you to fill in. If you have an older calculator, it'll actually say ABS and an open parenthesis. Either way, you would put what's inside of it. So you can go to your y equals. You're going to go to second, 0, abs, and you're going to type in x plus 2. Now, if you are using the newer calculator, you need to arrow out of those absolute value bars. The older calculator, you need to close the parenthesis. And then type plus. And then go into second, 0, abs, and then type in x minus 1. Either get out of the absolute value bars or close the parenthesis and then type in minus 2. Now be careful, because I had the experience, a couple of people who are using the app on the iPhones, their window was really large. So go in and check your window and make sure it's our standard -10, 10, -10, 10 window, okay? So when you do that, though, your graph should look something like this. And so we're just going to go through the pieces of it. So I can see as I start on the left, we're going down, so that means we're decreasing from the left, which is -infinity, all the way to that point right there, which is at x equals -2. And then what happens? Then we go this way, which is constant. So we start being constant at -2, and we keep being constant to that point right there, which is where x is +1. And then we start increasing again, and we just keep increasing. So we're increasing from that x equals 1 until we keep going to the right, so +infinity. And so there's where my graph is increasing, decreasing, or constant. All right, so then we're going to talk about local and absolute extrema. So when the graph of a function is increasing to the left of c, x equals c, and decreasing to the right of x equals c, then x equals c is the value of f is the largest. All right, so what it's saying here, it says this y value is called a local maximum of f. So what it's saying, because it says it's increasing to the left, decreasing to the right of it, means it's going to give you a hilltop, okay? So a hilltop will be a local maximum of that function. Local means it may not be the maximum of the entire graph, but it is the maximum of a certain area. And we can see that here in the picture that they gave us right here at D, okay? D is not the maximum of the entire graph, but it is a local maximum. D is the highest point within that circle that I drew right there. So it's called a local or a relative maximum. If D had been the largest point of the entire graph, then we would call that an absolute maximum. Same thing with the minimums. When the graph of the function is decreasing to the left of c and increasing to the right of c, then x equals c is the value of, then at x equals c, the value of f is the smallest. This y value is called a local minimum of f. So if we're looking for a valley, okay, hilltop, valley. So we can look, we have a valley right here, okay? Obviously, F is not the lowest point on my graph, but F is the lowest point within that circle that I drew. So therefore, F. Okay, guys, I don't know really for sure if you caught all of that or not. I just noticed that my thing was not recording, so I'm thinking you may have missed some of it. I'm going to run through it real quick, and then I'll catch it on the other if we didn't, okay? So a local or relative maximum is going to be the smallest point within a circle. You can see that like here on... Alright, some reason this keeps pausing itself because I had something showing up, some iOS update or something. Alright, so a local maximum is going to be a hilltop, okay? So you can see like right here I'm going to circle this D. D is a local maximum because it may not be the maximum of the entire graph, so it's not an absolute maximum, but it is a maximum within the circle that I drew. Okay? F is a local minimum. It is obviously not the lowest point on my graph, but it is the lowest point within the circle drawn around it. B is also a local minimum because it is also the lowest point within the circle that I drew around it. But B is also the lowest point on the graph, which means B is also an absolute minimum of our graph. Alright, so let's look some more at this. So it gives us our technical definition here if you'd like to read through it. But let's look at example 5. It says, based on the definition above, identify the following. So it wants me to find a relative maximum. So a relative maximum, remember, is a hilltop. And I see a hilltop right here. So my relative maximum is going to be the y value. And then where it occurs is the x value. So my relative maximum is 1, where x is equal to 2. Then I want a relative minimum. Now I see 2 of them. It doesn't matter which one I choose. So I'm going to choose this one. So I have a relative minimum is, that's your y value, so 0, where x equals 4. And then my other relative minimum is right here. So the relative minimum is -8, where x equals -3. But that one's a special relative minimum because it's also the lowest point that's on the graph. It's also an absolute minimum. Alright, and so let's talk about approximating extrema. So we'll explore techniques for finding extrema, maximum or minimum values for polynomial functions in a later chapter. For now, we'll use a graphing calculator to approximate extrema. So it says use a graphing calculator, use a graphing utility, sketch f of x equals x cubed minus 4x plus 1, then determine the local extrema, give values rounded to 2 decimal places. Alright, so first thing we're going to do is we're going to plug this in our calculator so we can find that maximum and that minimum that we see there. So we're going to go to y equals, we're going to type in x cubed minus 4x plus 1, and we're going to graph this. Do you remember, though, how to find a maximum and a minimum using your calculator? So if you want to find a maximum or a minimum, you're going to go to, so write it up here, and go to second, trace. And when you do that, you'll see number 3 says minimum, and number 4 says maximum. You'll choose whichever one you're after. So let's do that here. So let's find this first one at the top. So that's going to be a maximum. So I'm going to go to second, trace. I'm going to hit maximum. And the first thing it's going to do is tell me left bound. That means I want my cursor somewhere on the left side of that maximum point. And I'm going to hit enter. And then it says right bound. So I'm going to move to the right over here and get somewhere on the right side of that. My advice is don't cross the next curve though, okay, because you could mess up doing that. So just somewhere on the right side of it and hit enter. And then your calculator is going to say guess. We don't have time for that, so just hit enter. And if we do it right, and it says we can round to 2 decimal places, we should get -1.15, comma 4.08. Then let's go find this minimum. So it's a minimum, so I'm going to go back to second, trace, minimum. It says left bound, so I'm going to come somewhere over here. You're probably going to find it when you first do that. It's going to be on top of that maximum because that's what it just found and that's where it is. So bring it down a little bit, okay? Don't get into the curve there. So bring it down and hit enter. And then it says right bound, so come over to the right side of it somewhere and hit enter. Don't care about guess, so hit enter. And it's going to tell you 1.15, comma negative 2.08. And now that we have our ordered pairs, we can go ahead and start answering the questions. So it wants to know the local maximum value. Remember, when it's looking for the value, it's looking for the y. So it's going to be 4.08. And it occurs at, where it's happening is labeled by your x's. So x is equal to negative 1.15. Then it wanted the local minimum value, so that's the y, which is going to be, negative 2.08. And that's going to occur at the x value, which is x equals positive 1.15. I put the x there twice, so I confused myself. All right, guys, so I'm going to stop the video here, and then I'll continue on video 3 here over some more of it.